Okay, good morning, students. So today is the day two of the session on data engineering uh, in big data and cloud ecosystems. So we have with us Ms. Pooja Chopra, ma'am, okay, who is going to talk on the AWS and Microsoft Azure. So yesterday we had a session on Apache, Hadoop, and also we had discussed about Apache Spark and some hands-on session. And today we'll have so those were the topics which are taught in Unit 3. And today we'll be having a session, okay, which are related to Unit 4. So I expect every students here, okay, to be attentive and whatever the practical knowledge you gain from this session, okay, you please have a note of it. And if there is any doubt, okay, during the session, you are free to ask. Okay, ma'am will help you out, and and also in the end, you will be shared with the feedback. So that feedback will be your attendance. So I want all of you to stay till the end of the session, okay, and also cooperate with ma'am and be with the session, okay, throughout the time period. So the session is actually for 2 hours. So I want all of you to be there for 2 hours and gain as much as knowledge from this session. So take this as a placement point of view, for research point of view, whatever you want to learn, okay, you can get you try to learn from this session today. Um, Pooja ma'am, over to you now. I think we'll have a wonderful session even today. So, okay, thank you.
Yep, thank you so much, sir. So good morning, everyone. Like sir have already given the context. So for today, I'm mostly before getting into Azure and AWS, I would like to introduce like cloud computing. Why these cloud models came into in like where we talk about all these big three clouds like AWS, Azure, and GCP. And also like the entire course that you have is on data engineering, right? So in terms of like data engineering, why cloud is important, what are the data services in cloud to perform your operations. So I would want to give all that background before we deep dive into Azure and AWS. So yeah, let's get started. I'll share my screen. Please let me know once it's visible. Yeah. I hope my screen is visible.
Yes, yes, ma'am. Yeah.
Just a minute. All right. So let's first understand like what is cloud computing. So in general, like anyone can just let me know like what is your understanding of cloud? What is cloud computing? Let's be interactive today as well, so that this does not become like a one like time delivery that just happening from my end. Like I want all of you to be like as much as interactive as possible. So anyone can just like tell me like what is your understanding of cloud computing? Have you heard the term cloud?
Yes, ma'am.
Yes, ma'am.
Okay.
So, ma'am, cloud computing means using computer services like storage, server, databases, etc. over the internet or without instead of using physical servers or local computers.
Exactly. Yeah. So in general, like cloud computing simply means like use of computing resources as a service via internet. Now, when traditionally, when we were using like all the physical servers, or be it like the cluster, Hadoop, Spark, and things like that, right? So you cannot access them via cloud because right now, like traditionally, the cost of bearing the infrastructure, and then it is not accessible outside. So cloud computing in general gives all the users that they can access all the database resources via internet from anywhere, and as long as they need. So there is no like time boundary where this is only the time period that they can use like access those resources. So without even worrying about any maintenance or management of the actual resources. So in general, like cloud just refers to application services and data storage on internet. And you can also call it as like a combination of both hardware and software based computing resources delivered as a networked service, because via the network you can access all the resources on the cloud. Now it also enables user to access resources from any devices, like all the cloud devices that you can see, like your applications or anything running on the platform, all your infrastructure resources hosted on that infrastructure, so you can all access via the cloud. Cloud as an acronym, you can say like it's common location independent online utility. I just wanted to provide the acronym because when we all talk about cloud, like do we even know what it stands for? So just for your information, that is. Now, yeah. But why is cloud computing important? Now we understand that, okay, you want to access all your resources via cloud, via internet in the cloud. And we also understand the limitations of your on-prem systems, that you have to bear the storage cost, you have to maintain, and you cannot access it anywhere. So now via the network, cloud computing gives us that importance that you can access anywhere and you can keep it for how long you want, like be it your Google Cloud, or be it your iPhone cloud, or any other clouds in general, I mean. So like what are the other important things of cloud computing apart from the cost perspective? So it is when we spoke about like big data, right, in yesterday's session. So any problems of big data that we spoke about, like in terms of the volume, in terms of the velocity of the data that is been coming in, and in terms of the security aspects, so cloud computing solves those. It also provides like a low cost solution when compared to the on-prem server solution that we had, where you can access it at a minimal cost. And especially when you're using public clouds like AWS or Azure, you just buy their subscription, you store your data inside them, you use their managed services, and then things become simpler because it's managed by these public cloud providers. So in general, the importance of cloud computing is like huge. It's in various aspects, like it helps you manage your infrastructure by themselves, because just imagine that if you have a computer at home, right, or a laptop, or just imagine you have a system in general. Now anything that happens inside the system, you have to buy your antivirus software, you have to for your storage, if you're running out of your the normal storage which Google gives you, or your um, Apple gives you, then you have to buy those subscription, right? But say imagine that these were not there. If you had to just rely on your system's storage or your system's network, then it would have been like really difficult, correct? And you also have to ensure that it's always up to date with the upgrades, it's always up to date with the and the cost also implication, like like you can definitely scale, but that comes with the cost. But if you're using a provider service, then it is much convenient. So when we overall see the importance of cloud computing, it is like huge. Now, especially in terms of the IT sectors, what importance does cloud computing gives? I especially wanted to highlight IT in terms of the others, because that's where like that's something that's going to be useful also, right? When you start your professional career, and the IT organizations that we have as consumers when we see them. So the main significance that IT provides in terms of cloud computing are the applications are made easily available. So all the applications that an enterprise host is all on the cloud, and you can access it anywhere. So that's where when any organize or any enterprise that you see, when it's geographically located in multiple regions, like locations like US and then India, and like my teams also, there are like in multiple locations, mostly headquartered in US. So I'm also able to access the applications, and they are also able to, and as a developer as well, plus the end consumer, is because it is hosted on cloud. IT cost have been reduced. Again, the cost aspect comes here, where instead of you managing the physical servers and then you ensuring that it is scaled, it is always up and running. So if you're on cloud, things are like managed by the providers. You don't have to do any upfront investment cost. You definitely have to buy their subscriptions or their license for you to host. That also adds on to the cost, but it is way better than compared to the physical server cost that we have. Now, reliability is increased because it is on cloud, so you don't have to really worry about a DR or a backup. DR, what I mean is the disaster recovery and the backup in terms of fault tolerance. So just imagine if you have any physical system, and if something goes down, you also have to have another physical system which acts as a recovery of it, and you can't even like basically tying up these two physical system, that itself is a huge pain. But when it comes to cloud, you still need to do the disaster recovery, but because the things are hosted in cloud, so if from your cost perspective, things get much better and simplified. And all your data apps and things that are running on your phone or the Mac and things like that, right? Everything is like easily accessible. So, and in terms of just highlighting the eco-friendly part of it, because it is hosted in cloud and there is no physical server, so it's called the green credentials as solution, because it's not giving any environmental impact. This is again just for your information that because things are online, like on the cloud, and there is no environmental impact to it, so that's another advantage. So overall, we looked at like what is cloud computing, why it is important. We also understood like in IT, it is the most important. Now let's look at the architecture of cloud computing. Now, as you can see here, it is mainly divided into two components. One is the front end and the second is the back end. Now, in front end, it's basically what you see is the client infrastructure. So the client uses the front end, which contains a client-side interface and an application. Now, both the components are important to access the cloud computing platform. Now, for example, you can take like your Chrome browser, right, where we are hosting. This presentation itself is hosted on the browser, or I have downloaded this, but yesterday, if you would have seen, like I was hosting on the browser. So, and the backend part helps you manage all the resources needed to provide the cloud computing service. Now, it includes like those security, the data storage, infrastructure, runtime cloud, as you can see, like management and security layer. Now, there is a importance of each of these layers, which I'll go over, but ideally, like there are like these two components. One is the front end, and the second is the back end. I hope like you all are like following through.
Students, please be more interactive so that, and if there is any thing you need to ask in between, you can ask. Only in that we will get to know that you are following. Okay.
Excuse me, ma'am, I had a question.
Yes, yes,
Can we move on to the previous slide
yes,
before this? Yeah. So we were discussing the significance of cloud and IT industries.
yes.
So supposing I might be a consultant or a system architect, and I
Hmm.
was given a task to identify the requirements of a project.
Mm-hmm.
Then, based on those requirements, I had to design or I had to identify whether I need a cloud-based infrastructure or I can go with a local server-based. So, are there any thumb rules that you can point towards which might help us understand what are the basic requirements that need or must be checked out when we have to go for a cloud-based infra?
Got it, got it. Yeah, so that's a good question to ask, like whether you go with a cloud-based infrastructure or a local. So there are multiple things, right? So when you want something persisted, so you cannot persist on your local, correct? Because you will be able to run it on local, but how will I access it? So again, the main advantage of going with cloud computing is accessibility. So you have to host your infrastructure so that I can access it. So if your use case or your project requirement is that it has to be accessed anywhere and everywhere, then you have to go with a cloud solution for sure. Now, mostly like every enterprise, and I will show you the stats also in the following slides, like about the cloud adoption. Like 80 to 85% of the organizations are on cloud. Now, there are different types of cloud that again I'll go over, but mostly at an enterprise and a production level, everybody would go with a cloud-based solution, um, because you want it to be accessible everywhere, and the cost as well, because you're not just doing a MVP where you're going to like locally host it and you would do it. So when the project requirements come, like it's mostly like highlighted there that okay, you will have a cloud-based solution rather than a on-prem solution. But there are still few enterprises and startups which go with the on-prem solutions where they say that okay, we cannot go with the cloud-based architecture, and then they want it to be on-prem. So like they use RK2 and few other solutions that they have, like bare metal provisioning and things like that. But that is very minimal. Mostly any requirement, project requirement that you get is all on cloud.
Okay. Also, ma'am, supposing that we had to avoid the CSP lock-in for any product that I'm working on, and I had a few bare metal servers available for avoiding that circumstances. Then, what should be the key parameters that I should keep in mind when thinking on what should be persistent and what shouldn't be, and what can be taken on my bare metal hardware?
Uh, so it all depends on what you're trying to build, right? So if you're,
Mm-hmm.
what is your use case, for example? Now, just like one example that I can give you, a few days back, I was approached for one of the projects is using like the bare metal provisioning. So they had, they are like somewhere like a bank kind of a model where they have a couple of customers and they want to do like the banking services. Now there they had like diverse type of clients, some were on cloud, some were on on-prem, and they didn't want to basically they didn't have that bandwidth or the time to go to multi-cloud. So they already had an existing on-prem solution. Now in that, now the application banking services itself, if we say now that is divided into different things, right? So there are like some transactional services, there are like customer services, like the customer support that you provide, and there'll be a front end to it which is like if you are running from the mobile app, or people can even access by via net banking browser. Now that entire banking application itself is divided into different services. Now these services in the backend are tied up to microservices in a Kubernetes cluster. So I'm just not going into too much technical details because you would not understand. I would want to give it in a high level so that you
No, that's
understand
fair,
this.
ma'am. I understand. So
Yeah,
it's getting
yeah.
clear. I'm getting clarity on that. Yeah.
Yeah, so there'll be this backend services which has been tied up to. Now, each of these backend services will have a database associated with it where it will have the customer data. So, for example, let's say the transactional services. So, it will go retrieve the customer data saying that this person has done a transaction from this customer to a bank or from to any other customer or a friend or whatever. So, now that data needs to be persisted, right? So, there are two datas here. One is the client data itself, that okay, if a particular bank, one is the customers that are there in that banking, the person who is doing the banking application like HDFC or ICICI. Now HDFC or ICICI itself has its own employee database also, which is different. I'm not talking about that, but the user who are interacting with the applications. So definitely that persistence of data is very essential. But some other data like the logging events and things like that, for security purposes you need, but some other data you that is not persisted. So it all depends on the project requirements, that what data you need to be persisted, what events you want to look, what audits you want to make. So it is all like there is no such as common, there are common practices across, that you want to audit your logs, you want to keep the data of the customer persisted and any critical information, but there is no like specific uh, like you cannot say that every application or project will follow the same. It all depends on the requirements.
Got it, ma'am. Thank you so much.
Yeah, I hope that clarified. Like if you look at another application like e-commerce, us, right?
Mm.
So we all see like the order history and things, but that is tied up to the particular like customer, like if I'm seeing. But all the searches that I see, all the web that I see, like all the web searches and recommendations that I get, that is not stored in my
I guess, ma'am, we lost you.
Yeah, have we lost?
Yeah.
Ma'am, uh, I think, hello?
Ma'am is not audible, I guess.
Let me
Sure,
contact
sure,
her.
sir.
One minute.
Sure,
One
sir.
minute. Yeah, okay. Ma'am is joining back. 1 minute.
Yes, sir.
Okay.
Yeah, sorry, I'm back. I got dropped off Zoom, sorry.
Yeah, ma'am, you were discussing about e-commerce.
Yeah, I was discussing about e-commerce, right? Amazon example. So the client,
Yeah.
the recommendations that come in, so that is just persisted at the cookie level in our systems and also at the AWS backend side, but it is not persisted for a long time. It gets cleaned up. So ultimately, to answer your question, it all depends on the project requirements and the business use case that we have, that where we decide, okay, this data has to be persisted and this data has should not be persisted. But ideally, like when you're working at a enterprise large scale level, right? So mostly, like most of the data is persisted unless something that you think that is not needed or junk, like because on the data then you do your analytics reporting and lot of things, right? That okay, these many order purchases were there, these many people are liking this particular product, this is the most recommended or the most sold product and this is unsold. So how do they even derive at those analytics? Because they have that data stored, that data is ingested, and on top of that they, and when we talk about ETL and things like that going forward in next few minutes, you will understand this much better. So that's why we say like the data keeps coming in and we are handling like huge amount of data, the big data concept. So definitely the data is stored, and cleaning of the data happens like very minimalistic, when like somebody can only say like in large enterprises, like after years that you would basically clean up the data, or you would get rid of that particular data, but mostly you will store like all the data that comes in. I'll
Got
share
it, ma'am.
screen back.
Sure, ma'am.
Thank you. Yeah. Yeah, we were looking at the architecture where we were talking about the front end and the back end components. So front end mostly includes like the client infrastructure. It contains the application and the user interfaces which are required to access the cloud platform. Ideally, you can say like it's a graphic user interface, right? Like right now, even we are asked if you are accessing the Google browser or the Chrome browser or any such example. So that's like a user interface that it has been provided to us where we can like search through. Now, in the backend, it's associated with the backend infrastructure and things like that. But for you, for us, if we see like it's a UI interface very seamlessly that we can interact like chat GPT or things like that. So it's always giving a GUI for us, right? So that's the front end component, like all the web browsers, for example, that you can consider. Now, at the backend component, so there are like different things. Like first is the application. Application is like any software or platform that the client wants to access. So when we were considering like few examples, right? Like say Amazon or any example. So there are different applications that is running, right? So client tries to access the application over the internet. Now, the service component manages which type of service you can access according to the client's requirement. So it tries to access the application, but service component says that okay, which type of service you want to access, because there'll not just be like one application or one service, right? There'll be many kinds of it. Now, in general, if we can say there are three kinds of cloud computing services. It's called software as service, platform as service, and infrastructure as service. We'll go over this in detail in next few slides, but I just want to highlight here like what that application means, what that service means. Then runtime cloud, it offers that execution and runtime environment to the virtual machines. So where your infrastructure is hosted in the backend, so that runtime cloud basically provides you that runtime environment to run your to hold to execute your application ideally. Now storage, by the name we can say that it is that storage component where you can store your data. Then there is the management and the security that you can see. So the management component, it basically manages all of these components that you can see, like application, service, runtime, cloud storage, and your infrastructure. And security in the backend refers to like implementing different security mechanisms to secure your cloud system, like your files, be it your infrastructure, be it the interactions that the client is making to the application. So you definitely need the security layer to secure your application. So that's what it talks about. Now, this is overall the architecture of cloud computing, mainly in front end and back end components, as I explained, and in detail, like what we spoke about, like what back end includes, like service, application, and things like that. Now, um, holistically, if you would want to understand the cloud computing deployment models and the service model, we know the architecture, right? The front end and the back end. Now, there are like two deployment models and service model that is most important in cloud computing. When we talk about deployment model, is basically these clouds. So we have like different types of clouds: public, private, hybrid, and community cloud. And these deployment models are necessary in terms of accessing the cloud. So you know that your data is stored in the cloud, but how do you want people to access your cloud? For accessing the cloud, then you choose the corresponding deployment model. Now, will I go with a public cloud? Will I go with a private cloud? Or will I go with a hybrid cloud, which is combination of both public and private cloud and the community cloud? Now let's look at like each one. Like public cloud, for example, like it allows all the systems and services to be easily accessible by public, like all the cloud providers that we have, right? Like AWS, Amazon, and GCP. You definitely have to create a license to access it, but it's like an open source cloud that is given to all of us, correct? And it may be a little less secure in terms of that, because it's not a private cloud, but that is the whole concept of being public. Like um, for example, emails also that we send like via G Cloud, um, the Gmail suite that we have. So as part of public cloud, like it allows the systems and services to be easily accessible to general public. Now when it comes to private cloud, it is definitely increased security in terms of public cloud with the name itself that you can see. So it allows the same systems and services to be accessible only inside the organization. It's not going outside. And hybrid, with the name, you can see that it's the mixture of both public and private cloud. And community cloud is basically it allows the systems and services to be accessible by a group of organizations. Now, the difference between private and community is private is only within an organization, but community is you can have one or more organizations and you can say that, okay, it's a community. Sorry, was there a question?
Okay, you have a question?
Yes.
Anyone? Sahil Thakre. Uh, okay, ma'am, you can continue. There is, we'll take, ma'am, later.
Yeah, sure, sure. Sorry. Yeah, I thought there was a question. All right. So these are the different deployment models of cloud computing, and these are necessary in terms of what will be the access level when you are having a project requirement. So you choose accordingly, like public, private, hybrid, or community cloud. Now, in terms of, so we went over the deployment models. Then there is another thing called the service models. So when we spoke about the architecture, the service layer, right? And when I mentioned that there is infrastructure as service, platform as service, and software as service. So those are the three like cloud service models that we can see. And if you look at this particular slide, this is the difference between the on-prem infrastructure and your infrastructure as service, platform as service, and software as service. So it is in terms of what do you have to manage in terms of like both infrastructure and end-to-end application deployment. What all you'll have to manage in infrastructure of service, platform as service. So the ones that in green that you see, those are the things that you manage, and the rest is like managed by the provider. So you as a user, you only have to manage applications and data in platform as service, but in infrastructure as service, you have to manage applications, data, runtime, OS, middleware. But in software as a service, you don't have to manage anything. That's where most of us like go to software as a service, right? Like for example, all the like again like Gmail and things like that, like everything is managed. You as a end consumer, you just utilize that. So that's another example that you use as a software as a service. Like all the emails that we do, right? Like Gmail, Hotmail, and things. So that's a very good example of software as a service. So software is hosted in the cloud, and then Google Docs, and they can provide all the security features such as SSL, encryption, and different protocols that we can have. Um, so that's software as a service. Then platform as a service, it as a host provides software development platform, but basically the customer creates the software, and you have to manage your applications and data. A good example would be like Salesforce, if you all would know. And then infrastructure as a service, where you have to definitely manage your applications, data, runtime, OS, and hardware as like OS and your middleware. So that's about infrastructure as a service. But when it's on-prem, you have to manage everything. Your servers, you have to ensure it's backed up. You have to ensure the cost. You have to ensure the scaling part of aspect of it, and everything. It is on you to manage them. Now, this is an example, the difference of all of these. Now, let's look at, and one more thing that I want to mention with my experience over number of years in enterprise, right? So, there is a very thin line between these three. What I mean is, when we develop a product, say in cybersecurity industry, we have like a suite of products that we have developed. Now, when we develop a product, we basically give it as a software as a service. Like everybody would want to use that product. It's given as a software as a service. But now that concept is gone. What we usually focus on is we give those services as a platform. So you can call, so it's a combination of both. For example, if we look at any Microsoft 365, or even back going to the same example of Gmail, right? So if a Gmail is given to you, it is like a software as a service. You're sending mails, you're doing all the actions that is allowed. But Gmail is not just given to you, right? It is part of a G Suite. G Suite meaning you'll also have Google Drive, you'll also have Google Docs, you'll have a lot of other applications which is given to you. So when you basically create an account in Google, a new account as a new user, you're not just given the email service, you're given a lot of other services, right? Bundled together. So that's why there is this thin line between all of these three, where mostly like companies are moving towards platformization. They want to build individual products, but they also want to bundle it together and give it to you as a platform. So that concept is more seen in these days, like in my organization as well. Like the vision is mostly to go towards platformization. Somebody had a question or something to say?
Ma'am, I don't think. I think
Okay.
they might have by mistake unmuted. Yeah, we can.
Yeah, no problem. Yeah. Okay. So this is another like couple of stats that I want to show. What is the cloud adoption trend these days? So as you can see, like it is huge. Like more than 85% of enterprises are on cloud. Be it the any of the cloud adoption, be it the public, private, or be it the hybrid adoption. But overall, the percentage is like more than 85. So most of the enterprises are already using cloud services, and the cloud spending is also gone huge, definitely on in terms of your application, and it's crossed more than like 1 trillion by 2027. That's the prediction there. But everybody is on cloud. And when we compare like three different cloud providers, the most famous, right, the Amazon, Azure by Microsoft, and Google cloud provider, the most market share is by AWS, and then you have the Azure, and then you have the GCP. And these three cloud providers also, when you choose, there are multiple reasons. For example, like it also depends on. So if you ask me a question, that which cloud do I even choose? AWS, Azure, or GCP, right? So there are some use cases where which I will show in the next few slides, that these are the reasons that people go with AWS. These are the reasons people go with Azure. But at an enterprise level, based on my years of experience, I can say that sometimes it's not about what features these cloud providers offer. It's more or less about the partnership that the enterprise has with the provider. For example, in my previous company, they had a good partnership with Microsoft, and we used to leverage like Teams, Outlook, and things like that. So by default, they chose like Azure. Now, in my current company, we have a good partnership with Google, and by default, we are going with the Google Cloud provider. And though AWS is the most used, or as per the market share, that the trend that you're seeing, right? But still, we chose GCP is because the partnership that we have with Google, or the partnership that we have with Microsoft, and when you're running the services with them, so they give you huge discounts. So that is another aspect that you consider rather than like choosing the cloud. And in general, I would say like the cloud concepts are the same across, like the basics will never change. It is just that it is this, the naming conventions are different at times. Like for storage itself, if I would say, right, it's called storage account in Azure, it's called cloud buckets in GCP, and it's called S3 in Amazon. But underlying the base is it's like a storage component. So that's not changing. And definitely there'll be some features which each of these are providing, which are distinctive, but the concepts, the basics will never change. And when we speak about like data engineering, the whole course that we have, so why cloud is important in data engineering, we already spoke about big data yesterday. So data is like exploding, like a lot of data coming in, and the number that you would see, like that has been a projected number, that it has to reach like 175 ZB by 2025 end. And then on-prem challenges also, as we already spoke, like if you have to store this huge amount of data on-prem, just imagine the cost that it would be. Just imagine like the hardware that you would want to install for managing this, scaling, backup, fault tolerance, then the processing power. It's going to be huge, right? It's huge in cloud as well, but comparatively it is much much better. And cloud accessibility are the advantages, elasticity, cost efficiency, and with AI and ML booming these days, so it is definitely much important. And the most important is accessibility, as I kept on mentioning a couple of times, that you can access these services worldwide. So this is where it's most important in data engineering. Now let's look at the data engineering life cycle as alone. So it includes like these steps. First is ingestion, where the data is coming inside. Then you store the data. Then you process the data. Then you analyze the data and you visualize the data. Now, if we again look at yesterday's session, the hands-on that we did, right? So we basically took a CSV file, the Google Play Store CSV. Then we stored that into the Sparky session. Like I just want to correlate what we are doing here so that it's much better than rather than like having that stale understanding. So I just want to give that correlation. So we did pick up the Google Store data, we ingested that data, we stored it. It would it was stored in the drive, like you could ingest it from there as well, but we downloaded that data and we passed it as an input. Then if you remember, we did a little bit of processing the data. We created a schema and we did clean up, right, those, and normalize the data in that cleanup and normalization step that you would see. Then we had a couple of questions that we were given where we wanted to analyze the top 10 apps based on reviews or based on any other parameters. So we analyzed that data, and then we did the visualization where we projected them into bar charts and diagrams, and then we created the PDF. So you can like now relate to all those steps that we did in that hands-on. So ingestion, then we stored, then we processed, we analyzed and visualized. Now all of that that we did, we locally did it. Now just imagine on cloud if you have to do it. So there are services that cloud itself provides you to do this, and those are the data services in cloud. So for ingestion, you have the Kafka Event Hub. For storage, you have the S3 blob storage. For processes, you have the Data Factory, Databricks, and the AWS Glue. Then for analysis, you have Azure Synaptics. Then you have Redshift in AWS and Athena. And for visualization, you have the Power BI and the QuickSight. So this is like the mapping of all the three cloud providers that we have to these different stages that we can say, like ingestion, storage, process, analysis, and visualization. So I would like to stop here for a minute if there is any question, if you're like following through, or otherwise I can continue.
Ma'am, you can also tell that what are the practical aspects which you will be taking in this data engine life cycle for today's session.
Yeah, so I'll be walking through. So I'm almost like this is the only one thing that I want to go over, the ETL and ELT. So you would have
Okay.
already learned this in data engineering, right? But I just wanted to brush up through, because when we are talking about the data services, the processing layer, right? So it is that ELT and the ETL part, which you would already know, but I just wanted to go over once, and then I'll actually go into the data services. So, in the hands-on, I'll not be able to create these services because it incurs cost, but I can run you
Yeah,
through.
yeah.
I have the subscriptions of Azure and AWS, so I can walk you through the basic, like how, what, when you even spin up your account, what are the things that you see. So I can give you all of that. I'll just not hit the create button, but I'll show you everything else. And then I have a video demonstration as well. And then in practically to create it, because you all have the student account of Amazon AWS, so you can create a S3 bucket. So I can help you create an S3 bucket in there. So that's what I had planned. So let's get into this ETL and ELT. So as a name, you would know like extract, transform, and load, but ELT is like extract, load, and transform. So with the name, you can see like it transforms data before loading, which is ELT, but otherwise it loads the raw data first, transforms afterwards. Now, um, for an example, like this definition you would already know, but let me like take an example. Now, Spotify loads user logs into Google BigQuery, which is an ELT operation, and then it applies a SQL transformation afterwards, saving the time and compute. Now, when we all use Spotify, for example, right? Now, why did I choose Spotify is, now when you're basically listening to any music in the backend, there are some events or logs being generated in the event hub. Now, Event Hub is basically a event store where all the events or anything that is happening, even when you're hitting the play button of the music, right? That's an event or a trigger generated. That user is hitting to play this particular song. So that's an event generated. Now, after that event is generated, there could be multiple other events, like the user stopped the music in between, the user played another music. So for each of these actions that the user do, there are a lot of events generated. Now these events are generated, but along with that there are logs also generated, that okay, the user did so and so, and these logs are stored in the BigQuery. So they use Google, so that's why it's called BigQuery. BigQuery is another service that the Google cloud provider provides. So they do this ELT operation. So what they do is they first extract the information based on what user is trying to do, then they load that, and then they transform that, and then they apply some querying on that SQL data to say that this user is interested in this particular type of songs. It can give you recommendations on this particular type of songs. So all that querying in the backend happens with the ELT operation. So that's an example that I wanted to just give. So mostly for all the big data and the large amount of data that we deal with, so they first like extract the raw data. They first extract the information, then they load it, and then they transform that information. So that's what like happens. For example, the Spotify example also that I gave. So when we go over the Azure data services and the Amazon data services, you will be able to correlate these ETL operations happening in there. So let's deep dive into the Azure data services. So we have, in terms of data engineering alone, so these are the data services, but there are a lot of other services that Azure provides. Because we are interested in data engineering for the course of the curriculum, so that's why I listed the data services alone here, which is Data Factory, Synapse Analytics, Blob Storage, and Bricks. Now, the most simplest is the blob storage, because anything that you're storing in the file, right? For example, Google Drive also. So it gives you option to upload the files, download the files. So it's a storage. So similarly, inside the cloud, so every cloud provider has a storage component where you can store your files, perform actions on the file, persist all the files that you need is persisted in the blob storage. Now there are different types of storage also, like there could be like a table storage, file storage, blob storage, and different kinds of storage that we have, specific, but the most standard being the blob storage. And you can store like both structured and unstructured data inside the blob storage, like your logs, videos, files, images, um, anything and everything, like you can basically store in your blob storage. Then you have your Synapse Analytics. So Synapse is like Microsoft's cloud data warehouse. Um, it integrates with Azure Data Factory, Power BI, and Azure ML. For example, like another example, like real world example, if I have to give. So say like there is an airport, so airports, right? So if it has to analyze the passengers flow or any flight information that we need, right? So that's they in the back end, like the number of users which are coming inside the airport, the users which are going out, right? Once you check in inside the airport, so they all use like these Synapse Analytics in the back end. So the information based on the sensor data is ingested inside the Synapse Analytics. Then what it does is it analyzes like, okay, these many users came in, this is the check-in count. These are the different types of users that came in, and what was the experience of the users. So all of that like is one good example. So I would not say like every airport uses that, but definitely in the background, once a passenger check-ins inside the airport, so they inside the cloud, that data is ingested in Synapse Analytics, and then Synapse helps you simplify all the user operations, or gives all that analytics that is needed inside. Then there is Azure Data Factory. So that is another Microsoft's managed service. So all the ETL and ELT orchestration operations that we saw in the previous slide, right? These things that we do. So if we have to do it in Azure, then it is done in the service called Azure Data Factory. So it is like a drag and drop pipeline sort of a thing. So it will allow you to do all those operations inside the Azure Data Factory. Like you can do all your scheduling, monitoring, and everything inside the data factory. And some of these are like not used as a service as it is. It will be like a combination of services that you will use together. Like the data factory will be used with the Synapse Analytics. It can also be used with Databricks together. And for storing all your files that is needed for these services, it will be stored in the storage component. So don't imagine that all of these services will be used to just as a service alone, but it can be used as a combination of services. Now, Databricks is like a collaborative platform for Apache Spark in Azure, like whatever we did with Spark, right, yesterday. So that if we have to relate in terms of in Azure, so it is basically the Databricks. It is used for like big data processing, machine learning, AI workloads, anything with AI. Mostly you see like Databricks is the solution given by Azure for it. So this is just like an overview of all the data services that we have in Azure. Similarly, there are three data services in AWS. It's the S3, Glue, and Redshift. Now, S3 is exactly like the same as the blob storage that you see in Azure. So it is another like storage object where you can store your files and um, different kinds of files that you can store. Definitely secure and durable. Then you have your AWS Glue. Now, like here we had our ETL and ELT orchestration, right, called Data Factory in Azure. So similarly, you have Glue to do that in AWS. So again, like with the same thing that I was mentioning before, that it is the same concept wise, but it's named differently. Like here it is named AWS Glue, but here it is called Data Factory. There'll be definitely few differences when you start using them. It's not exactly the same as such, but concept wise it's the same. Like if you want to do a storage, then you do it in S3 if you're using AWS, but if it is Azure, then you do a blob, you do it in the storage account. Then Redshift is like the data warehouse platform that AWS provides. So it uses like columnar storage and MPP. MPP is nothing but massively parallel processing. So all the parallel processing of data that you would want to do, you do it via the Redshift. And it also integrates with the AWS ecosystem very well. Like for all your backups, encryption, you can use Redshift. There are multiple use cases of Redshift that people have been using, like all the insights that you want to get. We also took another example yesterday, right? Like sentiment analysis, where we wanted to get based on the customer feedbacks, we wanted to classify whether the feedback is being positive, negative, or neutral. So if you want to do those kind of sentiment analysis in cloud, then Redshift is a great service to use to. Yeah. So these are the different data services in AWS that we have. Now, this basically gives you a difference of, as I was mentioning, right, the same service, but what is it in Azure, what is it in AWS? It's Data Factory, here it is Glue, here it is Synapse, here it is Redshift, Blob Storage in Azure, S3 in AWS, Databricks in Azure, but Glue Notebook in AWS. And and you can also see like what mainly each of these are used for. Like if it is ETL or ELT orchestration, then these services, if it is storage, then it is S3 or Blob. But if it is for Spark based processing, then it is Glue and Databricks. And again, like in general, like enterprises go based on the partnership that they have, the discounts that they get, because that is because as an enterprise, when you see, you're not going to run this for once you tie up with a particular cloud, right? That's going to be like forever and ever. And it's not that they stick on to one cloud, they'll definitely have multi-cloud support, because their customers might not, like say, even if I have partnership with Google and I've gone with GCP, but my customer is hosted on Azure, then to support that customer, I cannot leave that customer, right, just because I'm on GCP. So enterprise tend to go with multi-cloud solutions as well. So for that particular customer, we will also go with Azure support, but primarily they go with the support that they are partnered with. So that's another there. So that's another norm that has been coming in, and which is already there in many of the organizations, that any solution that you build, any enterprise use case that you have, application that you build, you would want to ensure that it is hosted in all the three clouds. So with this, I would like to go with the hands-on now. So if you want, we can take a break for 5 minutes before I go to the hands-on.
Sure, ma'am. Sure. Students will have 5 minutes break in between. So by then, after that, I think we'll have session. Okay, I'll pause the recording till then. Uh, Ma'am, I started the recording. You can start your session.
Yeah, sure. So this is the Azure environment that I'm in. So in Azure, like once you
Ma'am, sorry to interrupt, ma'am. Students, you can see now the practical session starts. So please pay attention and you can ask any doubts in between. But that's what you can raise your hand and then you can ask doubt. Okay. So okay, ma'am, you can continue. Yeah. Yes.
yeah. So with the Microsoft account that you have, you can basically log into Azure. So I have logged in with one of the accounts that I had. So first thing when you log in, you will basically see a page like this. So this is the dashboard sort of a thing based on different services that you have. Like some of them are here, but this does not list like all the services. So you can go to the services page and this will list you all the Azure services that you have. So you can see, right, like if it is these are listed in different categories. So if it is AI plus machine learning, then these are all the Azure different services that it provides, like Azure machine learning, then bot services, and so on and so forth. Now if you want to do analytics, like data engineering also comes in here, right? So if you want to do analytics, then you also have your Synapse analytics that I mentioned, then data factory that is there, um, then Power BI. So all of these analytics, Databricks, so all those services comes inside the analytics section of Azure that it provides. Then for compute, you have your virtual instances, Kubernetes service, container apps, app services, then virtual machines that you host. So all of those comes inside the compute. So you can see like there are 33 of compute, 21 of analytics, and 20 of machine learning. Now, containers. Containers, the once your cluster as container registry for storing your Docker images, and these are the different services that it provides. Then you have your databases. You can see like all the databases. And then yesterday we also spoke about MongoDB. Cosmos DB is the most used in Azure in terms of the database. More than like the Azure SQL, we use like Cosmos DB. Then for DevOps, you have the Azure DevOps organization. Basically, as a just for your information, I want to provide this, that Azure is one of the cloud providers where everything end to end you can do inside Azure. What I mean is, so all these services you can create your resources inside Azure, but it also provides you platform like these a platform or a repository to keep your code, run your pipelines. Now you must have already all of you must have used GitHub, right, where you store your source code and you run your pipelines, and you also have GitHub Actions. But you have to use a third party product, like open source product called GitHub. So you're basically going outside of the Azure environment. But Azure is one provider that gives you the repository management plus running the pipelines in Azure itself. So if you also purchase this Azure DevOps, then for your enterprise you can create an Azure DevOps account and you can host your repository inside the cloud itself, and it also gives you provision to run your pipelines. Now, if you ask me question like what is a pipeline, data pipeline is different when when we talk about data engineering, right? A pipeline in Azure means, in terms of Azure DevOps organization, is basically where you want to uh, do something inside Azure. Now, basically, if I want to create a resource inside Azure, now I can manually come here and create, right? I can go to like one of these resources which I'll show over, but I can come here and I can manually hit this like create option and I can give the name and things like that and create. But if I want to do via, I don't want to manually create, then because say if I have like 100 resources to create, then it is time consuming, right? And I also want to ensure that all those resources are created with a particular standard. Then it is definitely a tedious process for me to create the resources in Azure. So then what I do is, there, like you have your languages to create applications like Python, Java, and so on and so forth. So for creating resources in Azure also, there is a language which is given by HashiCorp. It is called HashiCorp code language called Terraform. So with Terraform, you can basically create the resources in Azure. So when you start your professional career, and if you're working with cloud, then Terraform will be like a basic thing that you'll have to understand. Because without Terraform, you cannot create any resources in cloud. And every organization enforces you to have that understanding of Terraform. I'm just highlighting as a skill that is needed, but it's definitely not part of your curriculum, but I just want to highlight based on the experience that I have. So all the resources that we will create will be via Terraform, and I can share you all the docs and the links that is needed, like later, once you get onboarded in any of the companies that you get opportunity, right? Then you will be able to relate that, okay, in the guest lecture this has been mentioned, and this skill is actually important for me, and it is necessary right now. So yeah, that's about it. So again, going back to all the services, so so Azure is the only provider that you can have everything like cloud native. You can do inside the cloud itself, being in the cloud. Because if it is AWS or GCP, I'll have to use any third party repository management tool like GitHub or GitLab, or there are many others. But in Azure, I can choose to keep it inside the DevOps organization itself. Now it still has integrations to GitHub and other things, but that's again a third party integration, right? It's not inside the cloud itself that Microsoft provides. So this is about it. And then in the general category, you would see like all of these coming in. So in the services page, you can basically see all the different types of services in multiple categories. So just think like how many services Azure is providing. Like this is easily like about 500 services that if you would count, like 100 plus for sure. So yeah, and there are many more. Like these are just like Azure services, but you have something called Azure Marketplace. Um, where you can also do like third party integration. So you see this marketplace, right? So you can include like some third party apps like Chef and those from the marketplace also. So that support is also there. So this is about the services page. Now let's get back to home. Now anything that you do inside Azure, the basic concept is you have to first buy a license. Now in AWS also, you would create, when you created a student account, you gave all your information like email and others, right? So you basically have to buy a license inside Azure. That license is nothing but the subscription that you buy. Now you can have multiple subscriptions. The general standard is for every environment like dev, prod, and UAT. I will not go into too much details there because that would confuse you. But sorry.
No, you can continue.
Okay, okay. Yeah, so you basically create a subscription, and everything that you do gets tied up to a subscription. Like any resource you create inside Azure will be created then inside the subscription. So I have one subscription here that is created for me. So any resources that I will create will all be inside the subscription. In this particular subscription, all the resources will be there. So if I would see how many resources that I have, so all the resources, these are all the list of resources that has been created in the subscription that I have. Now inside the subscription, Azure mandates that all your resources that are created, right? They are all tied up to a resource group. So resource group is like one of the basic units that you can call, that every resource that you create has to be inside a resource group. So it can be in the same resource group or it can be in multiple resource group. That all depends on how you would want to structure your resources, or based on the requirements and use cases that you'll have. But that is a basic concept. So inside a subscription, so first you have a subscription. Now inside the subscription, you would have these resource groups. So I have like these couple of resource groups based on what I want to do. And then inside a resource group, you basically create your resources. So say if I want to create a storage account, so I'll hit this create button. So you can see like these are the storage accounts that have been created for me. So the first option that it gives, right? like subscription. So subscription, if you have many subscriptions, then it will show you a list and you can select which subscription it wants to go to. But since I only have one subscription, by default it is all directly picking it as pay as you go subscription that I have. Resource group, again, as I said, you can, since I have multiple resource groups, so I can choose whichever I want, or you can even create a new resource group. Storage account name is basically the name of the storage account that you would want to give. This has to be like a unique identifier, so you can give a name to the storage account. Then region is basically where you want the resources to be hosted in. Like these are all the different regions that Azure supports. So like geographically where you want all the regions to be hosted in. So right now you can choose like any of the regions, but the ideal goal why the region support is there is because uh, when you work on an enterprise, you want the customers of a particular region to be hosted in the same region. And the reason for it is, for example, if I have US customers, though I'm operational in multiple locations, I will keep the US customers hosted in the US region. The reason is because security, because the customer always want their native locations to be there. And second is accessibility. Now, say if I am hosting the US customer in Singapore region, it will definitely take me a little longer time to go to hit the Singapore gateway and serve the customer. But if it is located in its own region, then serving the customer becomes much faster. So these are like multiple regions why you would have like that geographical support of hosting the customers in their relevant region. So these are all the multiple region support that we have. So we choose that region. Then you choose the storage type. So as I was mentioning, you can store multiple types of files, right? Like you can store your tables, you can store your log files, you can store your normal file, PDFs, and things like that. So based on that, you would choose which type of storage you would want to go. The most standard one is the blob storage, but if you're dealing specifically with the files, then you go with Azure files, and otherwise you go with the tables and the queues. But the most recommended and the most standard one is the Azure blob storage. Now, again, the this is something called the SKU. Now you have chose that you have to use the Azure blob storage, but there are two types that you can go with. One is the standard type and one is the premium type. And you would see this for any resource that you create in Azure. Like they will ask you whether you would want to create the standard way or you would want to create the premium way. Now, standard way is basically when you are doing anything general purpose, like as the name says, right? So anything common, anything simple use case that you have, you will definitely go with the standard way. But if you want like more compute, when you want like more performance, when you want like things to happen, when your project requirement is like really critical and comprehensive, so that's when you go with the premium thing. So you can choose whether you would want to go with the standard SKU or you would want to go with the premium SKU. Then redundancy option. Now we have created a resource in US region, East US, but what if the storage account goes down? Like something happens, an outage occurs, and the storage account goes down. Basically, all your files you've stored there. So then it's a critical thing, right? You're going to lose your data. Like for example in your cloud as well, your phones, now if you don't back up the data or if you don't link it to a Google account, then if your phone is lost or if something happens to your phone, you're just going to lose all your photos and files, right? So same way, you will have to ensure that the storage account that you create where your files are stored, it is backed up. You should have that redundancy. So you can choose the redundancy options like local redundancy, geo redundancy, zone, and geo zone. And the reason that these are given is because, and people choose accordingly, is based on the cost also. Now, if my the reason that I'm using the storage account is not very critical, then you use the locally redundant, because you don't have to store it in a whole different location, because it implies cost, right? So as you can see, like recommended for non-critical scenarios. But if you want to have it in any other region, then you would have geo-redundant storage. Now, zones are basically inside this East US also. there are like geographical zones there, like zone A, zone B, zone C. So if you want to replicate in all the zones, then you use the zone redundant storage. And if you want a combination of both located in a different region, like for example, East US is always replicated with West US. Now East US 2 is always replicated with West US 2. So so you want East US to also be replicated with West US, and you also want all the zones in East US to be replicated with West US. Like if you're working with that critical of a project, then you go with the geo zone redundant storage. So based on your requirements, but this will definitely add on to the cost accordingly, because you're hosting your compute in that particular location and in all the zones, right? So based on the criticality of your requirement, you can go with any of the redundancy options. The standard is the locally redundant storage, LRS, that you don't want anything very critical, something standard that you're working on, then you go with that. Then there are a few more options here, where you want like TLS enabled, if you want like um, Entra authorization. I would not go over like each of these because that might not be really relevant to you right now. So, but just understand that in terms of access to the storage account, if you want to ensure that only people who have access to Azure in an organization accesses this storage account, then you check this box like this. So these are like some of the other options that you have in terms of security. Like if you want to use the TLS version, then you can use multiple TLS version. If you want to persist the copy of this from any other account, then you use like this particular option. But otherwise, you can just keep it as standard. Like you would not want to use any of these and just keep it as standard. Again, you have different types of access tiers. Yeah, if you want to allow cross-tenant replication, basically what does this option means is, now all of the resources that have been created in Azure are created under this Realm on Microsoft.com, right? So this acts like a tenant. So if I see my account details, so this is like one of the tenants that I have. Now, similar to this, I can have another tenant, like instead of Pooja at the rate Rayom on Microsoft.com, in Rayom itself, I can have another tenant. By tenant, I don't mean that the users, like for example, Rayom is one of the uh, customers, you can say, one of the tenants. Now, for example, Amazon, Flipkart, and Mintra are the same type, right? But these are like different tenants. Now, Amazon itself is a provider which is totally different than Mintra. But say, suppose holistically, if you imagine that Amazon, Mintra, and Flipkart work together, then you would create a tenant for Amazon, you would create a tenant for Flipkart, and you would create a tenant for Mintra. So, like that, if you want your resource to be accessible in, so if I'm working on Amazon now, but I want my resource to be accessible in Mintra also, then I check this box. So these are some of the options. Again, you can leave it as standard. I just want to focus on what is most important to not confuse you with a lot of options available. Then you hit next. Then networking once, so we are imagining that the network setup is already done. So if it is, you want your storage account to be accessed on public network, then you enable this. But you don't want anybody in the public to access your storage account, right? So you disable this. And then if you're disabling the public network access, you also have an option to create a private endpoint where people can access via private endpoint. Like it's the same concept like public cloud, private cloud, right? So you don't want public users to access your storage account, so you can give them option to access it via private, because otherwise how will I even access it? Like I have this subscription, so I am accessing via it, but today if I have to give you the access to the storage account, then I can do it via private endpoint. And then routing, we'll go with the default Microsoft network routing. We don't want to add anything new. Then data protection. So say I delete the storage account for, or accidentally the storage account got deleted. Now, will the data get cleaned up immediately? No. So if I enable this soft delete, what it does is, until 7 days I can still recover the data. So even if something gets accidentally deleted, if I check this box, then I can still recover that particular data until 7 days. So you can even increase this time to whatever you want. So until 67 days or 100 days, or based on your use case, if you check these boxes, then basically you will be able to retrieve that particular data even if your storage account gets automatically deleted or accidentally deleted. Then encryption, again, I would not go into too much into this. These are like all the standards that we have. Tags are, if you would want to label like your resources with particular name or application, like say I'm working on some banking application, then it's good to tag the account or the resources based on the application, so that so that whenever I want to retrieve the resources based on the application name, I can retrieve it. So if I just say Azure get the resources based on the name, label banking, it will give me all the resources. So basically for filtering it is much useful. And then when you hit review and create, it will basically create it. And say, see now it is saying validation failed. So whenever you're creating the resources, if there is something wrong, so it has highlighted that I've not given the name of the account, so it will give you it, so it will tell you that the name is not there, and you have to create the name, and you have to like correct it. And then again it's saying me that some information is not there. So if you see, like, the field cannot contain lowercase letters and numbers, must be between 3 and 24 characters. So I cannot use like any special characters, and this has to be a globally unique name. So if you see, like, this has already been taken, so I can give like any other name. Like mostly the test ones are already like taken. And if I go back to review and create, and it will validate and say if my configuration is correct. Yeah, so if you see now it is correct. So only now, once it validated the configuration in the backend, now only it is saying that you can create the resource. And you can also review all the configurations that you have given in here. Like if the name is correct, if the type is correct, and whatever you have created is all correct, you can review it here. So this is how you create a storage account in Azure. And similar to this, you would have all the other resources also created. So any resource that you would want to create, like if we go to the data factory, right, the data service, same thing. I don't have any data factory created, but if I would want to create, again same thing, you choose a resource group, you give it a name, then region where you want to create, version. Data factory itself has a version, like it's v2 version, latest running, so they don't allow you to use anything than the latest. Then you, if you want to integrate with the git, then you say like configure git later, or you can even configure it now. So if you see, like, it gives you an option to use the repository. You can use the Azure DevOps, the cloud native one, or the GitHub one. So you can choose to use the repository that you need. Then the networking, again, like if you would want public access, or if you don't want people to use via public, so the most recommended is to use the private. Then encryption if you want, and then you review and you create. So all the resources in Azure are created the same fashion. Like you just need to, based on the configuration, you have to provide what you would want to create, and you can create it. Another thing that I want to show is this shell. So there are multiple ways that you can create the resources, right? One is like the manual way, like you go to the UI and you see the options and you create. Another is where you can create via the cloud shell. Now even when you are creating any resource, right, like you have your Python or anything that you're working with, so you can create it via the command line, right? So similarly you can create it via the command line after connecting to the Azure credentials with AZCLI. You can create it from your terminal as well, be it your Mac or Windows terminal, or you can create it inside the cloud shell. So Azure itself give you the CLI support, where once I don't want to launch this because in this also in the backend it uses a storage account which incurs cost. So I don't want to launch this now, but ideally what I want to show is you can run AZCLI commands. It will give you a terminal window like this, where you can run your commands here. So it will give you a, with AZ-CLI you can run your AZ commands, like whatever AZ commands that you do, right? Like for example, I want to see the version of the Azure now, so I'm running this AZ version, which is the latest version of Azure that I have. So if you see, like I'm having 2.7.0. So all the AZ commands that I'm running here, I can run it from the this console cloud shell. And same, and that is there in any cloud provider. Even AWS has it, even GCP has it. So even I can create the resource via the CLI. Like I can do like AZ create. If I just do help, right? So it will give me the options of what resources that I would want to create. So you can play around with this as well. Like create is not there, that's why it's giving me. But whatever I would want to do with AZ, I can just do this help, and it will give me all the options available to create resources inside Azure. So that's another way of creating resources.
Ma'am, one doubt.
Yes.
Are there any like power virtual agents kind of thing, like in power intelligence? We are having that power virtual agents, or where they can we can create connectors, all those things. The same thing. Does Microsoft Azure have that kind of option?
Yeah, Power BI it has.
Yeah,
For
and
what?
yeah, in Power Virtual Agents, there are to create connectors, to create a pipeline or kind of thing. There are some agents which provides that support. So even for this Azure Databricks, instead of manually doing it, can are there any agents available in the Microsoft Azure? Just
No,
curiosity. Yeah.
no, to create the resources, there are like no agents as such. That AI integration is
Like
separate.
yeah, because if there are some new users or something, like if they want some help or something to create something, uh, for that reason, are there any agents available where they can do, means are there options available in this
Yeah,
just
options is definitely available. Options is definitely available. You can use the so there are few things here. So you will have to integrate your Azure with a chatbot or a AI, right? Which will
yeah,
write your
chatbot,
code.
yeah, yes, yes,
Yeah,
yes,
yeah.
yeah.
Chatbot option is definitely there. So in the AI services, if we go, like you can leverage all of that. But to create the resources, the options that are available is, so you can use the AI, but you'll have to do all the setup. But as a bare minimum, like if you just have your subscription and if you want to create the resources, then what you can do is like you can do it via Terraform. So the Terraform that I was talking about, right? So Azure itself provides you like, let me go inside this. So if you see, this is by HashiCorp. So this is a language used by Terraform, like or be it like any cloud provider. So you would see, if I would want to create app service, or let me take a simple resource like resource group. As I was saying, like that's the bare minimum, right? So if I would want to create a resource group, so I install, like how you have your AZ CLI, I install the Terraform CLI, and then this gives me a snippet to create the Terraform. So what I just need
Oh,
to do is I need to copy this code, and then I need to pass the name and this thing, and then run the Terraform apply. Um, so inside Terraform, there are like three commands, like how you do your Python and you pass your Python file, right? So similarly, there is a way to do like Terraform plan and apply. So when you do the apply, it creates the resource inside Azure. So any new users mostly go with this is the standard that they learn Terraform and they do it. This is very straightforward if the documentation is there. But yeah, it can definitely be done via AI also. So you can say AI to create a resource, it will create a resource for you. But you'll have to do the setup of AI before for that. But this does not
oh,
require anything. Like you can just install the Terraform CLI, go through the documentation and do it. But for the AI, you'll have to do the AI integration.
okay, ma'am. And that also come with the type of the uh, user, no?
Yes, yes. Yeah,
Yeah, yeah, okay.
yeah.
Uh,
This is about Azure. Then before I move
I-
on to AWS, any questions or anything, then I can take it.
yeah, ma'am. Any students, they can ask. Ma'am, even while creating a storage, you went till that create option, but you have not clicked on that option.
Yeah,
So once
because
we have reached there,
Mhm.
was there any, is there any cost involved?
Yeah,
Like,
yeah, it is. Yeah, yeah. Anything that you click create, it is cost involved. So this
okay,
subscription that I have, like I don't want to like create anything because it incurs cost. This is I though it is in my name, I'm using the subscription as part of the RIOM
yeah,
organization. So I don't want to
yeah,
create any resource. But yeah, it will incur cost. Anything you do inside cloud, when you create any resource, it incurs cost. And you can see the costing also. So if you see this cost management, right? So for each of the resources, you can see like the cost associated with it. You'll have to enable that, but um, it's not enabled. But yeah, like you'll be able to. So there is this cost management thing. So this also like you'll have to like basically enable it. I've not like configured. I've not set up my subscription to show me the cost. So that's why it is not
okay,
showing it. But once you enable this, then you will be able to see the cost associated with the with each of the resource. So
okay,
it can also give you all those analytics when you come to the cost part, right? That okay, my subscription, these many resources are created, this is the cost that it's incurring, and all of those analytics you can get inside itself.
okay, okay. Students, any doubts
And there is
related to this?
another
Yeah.
Azure service called Microsoft Advisor. So what
Okay,
this does is this advisor that you see, right? Microsoft Advisor as part of the cost management itself, that I was seeing. So it also gives you like recommendations. So for example, if you would seeing this, right, review disks that are not associated with the VM. Now this is simply incurring me cost. Like in the whenever I create a virtual machine or a compute instance, so in the background a disk gets created. Now, but this, if you see this recommendation, what it says is a disk is created, but it's not associated to a VM. So probably what would have happened is when somebody deleted the VM, right? So there is an option that you have to check box where you have to say that you have to delete the disk associated with the VM also. So somebody didn't check box that, and the disk is left alone, but it's not associated with the VM. But I'm incurring cost for this disk, right? So if you see, like it also give you recommendation saying that you have to review the disk, and if it is not associated to the VM, then delete it because it's incurring me the cost. So Microsoft Advisor gives you all those recommendations on your resources. So there are a lot of like good services in there that can give you all the cost, analytics, advisory, everything. Monitoring solutions are also there to keep monitoring your applications. If it is going down, if it is running fine, if the bandwidth is good. So all of that is there.
okay. Will it show me how much space it has like stored?
Yeah. It'll show you
Yeah.
that as well. Yes. Yeah, you'll have to
Okay.
enable those options like every resource, like cost analysis also, like every resource has that analytics option. So you'll have to enable that. It will also show you like how much space is left in that disk, how much is utilized, everything it'll show you.
Okay. And what about after the storage? If I want to proceed further for any machine learning prediction and all.
Yeah, you
So
can do that. You
or
can do
do
that.
okay.
And you can also scale it. Like say, if like we all do this, right? When we
Yeah.
create a particular resource, we create it with standards queue because we don't want to. Now itself, I don't know that I'll have many users coming in. For example, when I start a company, just a crude example, I'm starting a company. I have like 100 customers. Now for 100
Mm,
customers, I will go with standard queue to bear the cost. I don't want to go with premium queue. Now tomorrow, these 100 customers get scaled, and if I have like 200 customers to serve, and or definitely standard is not the option for me, right? So I can also scale my compute to change it to premium. It will have a little bit of downtime again based on the services that you have, but that is very minimal, and it is seamlessly changed or scaled to the premium where it can serve like multiple customers, and you can also integrate with all ML solutions and things like that, so everything is doable.
okay.
Yeah, probably once you have to like get onto it, like do a lot of practices, and then you'll understand like all of this. And again, like as we saw, like there are so many services of Azure, right? So you would not like myself, I wouldn't have like gone over or got an opportunity to try off all these services that we have. But yeah, you can try off at least like what is useful to you based on your project requirements, and you can try out all these.
Okay.
Yeah. Okay, so that's about Azure. Then we
Yeah.
can probably go with AWS.
Yes. So no questions, Miss. I think students are clear with that. I hope. Yeah. Anything before we move to AWS? Any doubts? Any students? Okay, can acknowledge yes or no?
No, sir.
No, right? Okay. Okay. Ma'am, we can continue.
Yeah.
Yeah.
Again, like so this is how AWS looks like. So I have logged in with one of the accounts that I have. So I can see my account in here. AWS is a little different than Azure, but again, like going back, the concepts and things are same. So this is one of the accounts that I have. And if you see like there is also a support that I can enable for the regions that I want. So you would see like all of these are disabled, and these are all the regions that it has been enabled by default. So once you log in and then you see like you can, if you have enabled a particular region, it will show you like United States or Asia Pacific or things like that. But if you have not enabled any particular location, by default it will go to global. So that's why it has selected like global account for me. Now, inside this, like similar to Azure, you have your data services. So inside the services page, you can see all the services, and you can like similar to the blob storage, you have your storage account here. And if I have to create a bucket, so you would see, right? It looks like this. And if I have to create a bucket, I can just go to create. Again, same thing. Like if I want a general purpose, and I go with general purpose, or if I want to go with little bit better one, then I go with the directory based. Zones, if I want to keep it only in a single zone, then I choose like AZ1. But if I want in any other zone, then I choose like AZ3. Then we'll go with the standard one. Then you can pass your bucket name, which has to be a globally unique identifier. If you want to copy any settings from an existing bucket, like say I already have a bucket created and I want to create when the second new one that I'm creating, the configuration, I don't want to spend time writing all of this, like selecting all these options, right? So I can choose an existing bucket, and that will basically copy all the configurations for me. So this is like an easy option that AWS has given. Then in terms of access, that I don't want anybody to access my bucket, then you do like ACL disabled. But if you want like how in Azure we had like public and private access, right? But that is like if you checkbox this, it will block all the public access. But in terms of the storage account ownership itself, if somebody has the account credentials, then they can access. But if they are part of any other account, then do you want them to access, or do you want them not to access in that particular organization? Then you can checkbox like these enabled and disabled options. Then this is the most recommended, like always block public access, don't allow anyone in public to use it. Then if you want to keep versions of the bucket, like say today I uploaded a file, tomorrow I'm going to upload another file, but it's the same file, but I have just included a little bit more of information in that. Then you basically have an option to version that particular file. Say today it was version 1, tomorrow I have done some modifications and I store it as version 2. So if you enable the bucket with versioning, then you will be able to maintain all the versions of the bucket. But if you disable it, then you'll only have provision to store one file, which will be the only version available. Then tags are nothing but, as we saw in Azure, if you would want to label your resources, right? When you're dealing with like n number of resources, the standard is to tag the resources so that you can retrieve the resources with the tag name. So if I just say like tag name equal to banking or whatever, then it's easily giving me, because if I say like if I have 100 plus storage buckets created, and if I have to retrieve search something by the name, then I won't remember the name, or I won't remember like what all is created, right? And sometimes what happens is, like, if you're new to the subscription, or if you're new to the environment, then you won't even, nobody is going to tell you that, okay, retrieve the bucket with this particular name. You have to figure it out yourself. So that's why, like, the tagging is most important, where you just give the application name and you filter out all the resources that have been created for that particular application. Again, encryption, if you want to encrypt your storage account with a key and then people can access it with a key, then you enable that. But otherwise, you just keep it like as a standard, and you can leave it. So these are like the standard options that it does. And then once you create a bucket will be created for you. So there is no like validation that happens in AWS like in Azure. But and again, everything is incurring a cost, like anything that you would create. So, but it will give you a validation that say that something, say if I've not given a name here, right? And if I just hit create bucket, it will tell me that I have to create a name. So those options are there, but it will not give you like in Azure, like that holistic configuration view that we got, right? In Azure, it will not give you like that in AWS. Again, change nothing. There are differences between Azure and AWS. The concept is the same, as I've kept on stressing, but few differences that you can see. So you can hit like create bucket, and you can create the resources. Um, yeah. Uh, and then like the dashboard that we had in Azure, like this is the home page of the AWS, where you can see the applications which are running. And here, one another thing, advantages in AWS is you can see the cost upfront here. Like there, we had to go to the cost management and enable it and then see, right? But here, once you create your account itself, you can see in the billing and cost management this wizard, where it will show you, because right now I don't have any resources created, it is like zero, but it will show you upfront the cost. And in AWS also, you can get recommendations saying that these particular resources, to lower the cost, you can do these many configurations, you can update, you can delete these resources. So all of that provision is there in AWS also. You can also get a deep breakdown of the cost. For example, when you create a VM, right? In the backend, there are like too many things that gets created, like a disk. Then networking few resources gets created when it allocates the IP of the virtual machine that you're creating. So for all of that, so when you see at the cost, you would only get a cost of the virtual machine. You'll not get the cost of the disk. You'll not get the cost of the type of virtual machine that you're created, right? But in AWS, you can get that detailed breakdown that, okay, the virtual machine itself costed me like this much, but the disk costed me this. For getting the IP, it costed me, the interface costed me this. The instance group did cost me this much. So you can get that detailed breakdown for each and every resource in AWS also. So probably if you all have the student accounts, you can try creating a storage bucket now. And if there is any issue, then I can help you.
Students, you can, if you're having, I think account, you can start doing it. You want 1 or 2 minutes?
Yeah, you can take your time.
Yeah, I think students can take 2 minutes of time. And if you're having AWS account, and ma'am can give one scenario, and you can start working on it. Ma'am, let's give them one more time,
Sure,
and
sure,
I
sure.
think,
Yeah,
yeah.
yeah, sure.
Okay, students, by then, please, okay, you can start your AWS thing, and you can. I hope all of you are having AWS account. Students,
Yes, so
okay. So,
Yes,
are you able to do now? Okay, so we can uh, start doing that. Okay, we'll give you 1 or 2 minutes, and then you can start. Once you are done, you can please acknowledge.
Yeah, you can just create an S3 bucket and you can try uploading that Google data CSV that we had downloaded yesterday or any other file that you would want to upload. Just create a bucket and upload the file.
If anybody, then they can share their screen, and that would be even more. We will get to know that
Yeah.
whether you're going wrong. Yeah.
And the reason
Yes.
I chose to create the storage of the S3 bucket is because with the student account, you would only be able to do that. The other data services will all incur cost and you won't be able to do it with the student account. So that's why I chose to just keep it with the S3.
Okay. If anybody can share their screen, okay, that would be helpful. Anyone who is willing to share the screen? This will help others also, other participants also, and ma'am can also guide you. So nothing to worry. Even if you are going wrong, okay, you can share your screen. Yes. Anybody? Yes.
Yes, sir.
Okay. Can you share your screen, please?
Yes, sir.
Yeah. Okay. You can open that window. Okay. Now,
So what to do means exactly?
yeah, ma'am. Would you like to
This is the
please?
Bro,
lab that you've started, right? You don't
Yes,
have the student account, like the AWS, if you click on that, does it
yes,
open?
click on AWS.
Yeah, yeah, just click on the AWS. Yeah, so this launched the console for you. So you can just search for S3. S3. Yeah, this is the storage that Amazon provides. So you can open that. Yeah. Yeah, just click on create bucket. Yeah, so you can choose the general purpose. You can give the bucket name, like any unique name that you would want to give, globally unique. Any name you
can I
can.
give uh can I give the my name also means Yash?
Yeah, yeah, try it. If it is not valid, it will give you error, but you can try.
Then
Yeah, so we'll not choose any existing bucket configuration. We'll leave it disabled. You can leave that disabled. Then scroll down. We'll also block the public access. We don't want to give it. Uh, yeah, that's correct. Just scroll down. Then versioning also will disable because we are just creating a simple version. Tags probably you can give like demo or something like that. Any like uh, it's part of the demo, right? So you can give it as demo and the value will be like um whatever, like intro session or something, the guest lecture or whatever you would want to give. Basically the key is we give it as like application and the name, the value we give it as like banking or e-commerce or things like that, but this is just like a test one that we are
I
creating.
think you need to hit that add new tag. Yes.
No sir, add new
Click
tag.
on.
Add new tag is like you can have multiple tags, so this will take it. So
This
just
will
click
take
on
it,
that.
right?
Yeah, yeah, yeah. If you want to add multiple tags, right? Like if you click add new tag, it will give you another prompt down. So you can add like 2, 3 tags. Just click on that.
Okay.
Just for example, I want to show. Yeah, so you can add another one down.
Okay.
Yeah, so you can have multiple like that. Yes. Yeah,
Okay.
yeah. We'll leave it like default encryption.
Hmm.
Then bucket key, and then you can scroll down. Advanced settings, I don't think we need to change anything. If you expand that, yeah, we'll leave it disabled only, and you can just hit create bucket.
Down.
Bottom right
Down,
side,
down, down,
down,
down,
down,
down, down.
down right side. Yeah,
Create button.
yeah,
Right side. Right side.
Can I
Have
create
you
a
clicked
bucket
on
now?
this?
yeah. You can create. Yeah,
Yeah, yeah.
yeah.
Have
So
you
if you
clicked?
see, like, it
Okay.
gives error saying Yash cannot contain uppercase letters, so you'll have to give lowercase.
Okay. Give yes 1 2 3 or something like that. I think that will do.
Yeah.
This is also showing error now.
No, it says that Yash 1 2 3 exists. So what you can do is you can give Yash MIT or something. Like, you'll have to
Okay.
give a unique
Yeah,
name.
unique. Yeah. Yes, MIT 1 2 3 something like that. Or yes, MIT something. Yeah, I think this. Yeah, yeah, correct. Someone might have created bucket.
Yeah. Yeah, see, it got like successfully created in USD's region. It also gives you that creation date. Now you can go inside the bucket. If you can click on that Yash MIT 1 2 3. Yeah, so now here you see options of uploading your files. So you can like upload your file. So if you click on that upload,
Down, down.
Yes.
No objects. You can see that no objects. You don't have this below. No, this one.
yeah. So you can choose files like add files, or you can just do drag and drop as well from your system. So you can just add a file.
Any, I think CSV file will do, no, man?
Yeah, any file will do. Any format, any file will do. Any doc,
Any
anything
file.
you can add.
Okay. Yeah. Yesterday's file you can upload it.
Yeah,
Then
so it's
I'm
already uploaded. So as you can see, like it is 70 KB. It's been uploaded. And you can just hit upload in the bottom.
And permissions and properties, ma'am. Anything?
Yeah, permissions,
Can
you can
you?
expand that. That's basically, so one is the permission that you put it at the account bucket level, but at the file level also you can set your permissions, like because a bucket can have multiple files, right? But if this is a
Hmm.
sensitive file, and if you don't want a particular users, like an Azure, an AWS account also will have 100 users, right? In an
Hmm.
enterprise. Now, out of the 100 users, you don't want a particular user to access a particular file, then you can give those permissions. Like, is it like publicly as accessible or not? So all of that you can set in that permission section. Or otherwise, you
Okay.
can leave it default that whoever has access to AWS account will be able to see the file. So now it is uploaded successfully. So you can just close this.
Can I give back?
Yeah, yeah.
Means
Or you can just hit that close that you see inside that in the yeah. Yeah, so if you see here, it has been successfully uploaded and the storage class is standard. And then if you
yes,
click
yes.
on other like that metadata, properties, permissions, so you will be able to see like what are all the parameters associated with the one that you have created. Um, there is no metadata created for this, but if you want to create metadata, then you can create. Then properties will show you all the parameters if you click on the properties. Yeah, it will show you all the
Yes, ma'am.
properties associated, and the most important one is that ARN name. So whenever you want to access retrieve this storage account, so every resource in be it in Azure or AWS, right? It is
Yes, yes.
associated with a unique ID. So in AWS, it is called the ARN. So any resource is associated with Amazon resource name. So if you that will be like an identifier for the resource that you have created. So if you want to retrieve this resource in any other resource, then you access it via the identifier, which is that ARN name.
Okay, ma'am.
Like for example, if you're using Data Factory, or if you're using like Synapse Analytics, where you want to link your storage account, right? So then you link
Yes.
it via the ARN name. And then you can
Okay,
see the
ma'am.
tags that you created as well. It is showing all the parameters. So basically, based on all the configurations that you have used to create the storage account, all the parameters will be shown in this properties section. Yeah. Anyone else is facing any issue creating the S3? If anyone has any issues or wants to understand any service, then can please let me know.
Ma'am, this is done now. So can I stop sharing?
Yeah, this is done. Yes. Thank you.
Okay. Thank you, ma'am.
Thank you.
Okay. Any students, if they want to share, they can share their screen. Ma'am, are you going to show GCP also, or only these two? Azure only?
GCP, I didn't create an account, sir. I thought like just Azure and AWS, so I didn't create it.
Okay, no problem. Any students? Okay, you want to ask something? Any doubts? Yes. Okay, you can. Okay. You want some time to work on, or you would like to ask doubt now? Sahil, Pranav, okay, anybody? Omkar, Shitole, Nakshatra, anybody? Any
No, sir, no
students?
doubts.
No doubts, right?
Yes, sir.
Okay, okay. So, ma'am, is it done or any other contents are there?
No, sir, that is done. That's all I had.
Yes. Sir. Okay. Thank you so much, ma'am, and I would like to uh, thank ma'am for taking your time and we had wonderful 2 day session on this data engineering, big data, and cloud system, cloud ecosystem, and I'm very pretty much sure that that students uh, um, have learned all the things related to AWS and Microsoft Azure. Uh, okay, so we will be sharing you the recording. Okay, after this session, that is day one and day two session recording will be shared to you. And by then, okay, you can also go to the attendance. Okay, the I have shared you the feedback link. Okay, so that feedback link is nothing but your attendance, and just go to that link and we can give the feedback. And um, I would also like to thank all the participants here for being here for both the days, and also we have some faculty participants also. Rashmi ma'am is there, and we had Harshad Lokandi sir yesterday. And would also like to thank our management for their support for conducting this workshop. Our Dean Ganesh Patak sir, our HOD NP Kulkarni sir, and with special thanks to you, ma'am. So you had taken 2 days. You had taken so much of pain in delivering this guest lecture. Rashmi, ma'am, would you like to add something from your side? Anything?
I would like to thank ma'am. It was very well explained, and we would like to keep in touch. I already told sir that the recording that he has done for both the sessions, it will be quite good to go through again. Very systematically planned and beautifully explained, ma'am. Thank you so much.
Thank you so much, ma'am. And again, thank you so much for giving me this opportunity to be part of the university as a guest lecturer. I'm really thankful for this opportunity. And to all the students and everyone who took their time to be a part. And a special thanks to sir for all the coordination in terms of planning this 2 day session and scheduling it. So thank you so much, sir. Thank you, everyone. Thanks a lot.
Ma'am, thank you. Thanks to you, ma'am. And we would like to have future collaboration with you in terms of guest lecture or any expert session for us.
Yes, sir. Yes, sir. We do look
Yeah.
forward to that with ma'am.
Sure, sure, sure. Thank you so much. It'll be a great opportunity. Thank you.
Yeah. Students, till then, please go through that link, feedback link, and that feedback link is your attendance. Okay. So you only if you are marking that, giving that feedback, okay, that will be considered as your attendance. Once you are done, okay, I think you can leave the session. Ma'am, meanwhile, thank you both of you, and I think I will stop the recording.
Thank you, Aditya, sir. Thank you, ma'am.
Thank
Thank you,
you.
ma'am. Thank you.
Thank
Yeah.
you.